Hey, welcome. Ever stopped and wondered how the internet actually works? Like really works? Well, you've come to the right place. We're about to break down all the essentials of computer networking. And here's the fun part. We're going to test your knowledge as we go. So you ready? Let's dive in.
Okay, so here's our game plan. We're going to hit 5 key areas. First up, the big picture, what the internet really is. Then we'll get into LANs versus WANs, followed by some network blueprints. After that, we'll uncover how we find websites, and we'll wrap things up with a look at speed and the cloud.
All right, let's kick things off with a big one. Seriously, we use the internet every single day. But what is it? I mean, really? You might be shocked to find out that what most people think it is, well, it's just plain wrong.
And here it is. This is the distinction that trips up so many people. The internet itself is the physical hardware. All the cables under the ocean, the satellites, the servers. The World Wide Web, that's just a service that runs on the internet. Here's a great way to think about it. The internet is the entire global road system. The web is just one type of vehicle driving on those roads, like cars and trucks. Makes sense, right?
Okay, so if the internet is this massive, planet-spanning thing, where does your little home network fit in? That's a great question, and it leads us right into our next topic. We're going to compare the two main types of networks, LANs and WANs. And really, it all just boils down to two things, scale and ownership.
Right, so a LAN, or local area network, is probably what you've got at home or what a school has in a single building. It's small, geographically speaking, and you or the school own all the gear, the router, the cables, the whole shebang. A WAN, a wide area network, is the complete opposite. It's enormous. Think of the internet itself. It covers huge distances and relies on infrastructure owned by giant telecom companies, like those telephone lines.
All right, get ready. Time for your first challenge. We've got a youth center. They set up a network with 20 computers, all inside one building. I need you to give me 2 reasons why this is a LAN and not a WAN. Think back to those 2 key differences we just talked about.
Okay, you know what to do. Go ahead and hit pause. Scribble down your 2 reasons, no pressure. I'll be right here when you're ready.
And we're back. How'd you do? Did you nail it? The 2 big reasons it's a LAN are, number 1, it's stuck in a small geographical area, just that one building. And number 2, the youth center owns all the hardware themselves. And this brings up a super important pro tip from examiners, so listen up. The difference is always about distance and ownership. It has nothing to do with how many computers are on the network. That's a common trap.
Awesome job on that one. So now we know the difference between the types of networks, but how are they actually put together? We're talking about the architectural blueprints here, or what the pros call topology. Let's focus on 2 of the big ones, star and mesh.
So when you're building a network, you've got some choices. With a mesh topology, it's like a web. Every single device connects to every other device. The huge benefit? It's incredibly robust. If one connection fails, the data just finds another way to get there. There's no single point of failure. On the flip side, you have the star topology. Everything is much simpler. All devices connect to one central hub or switch. This makes it super easy to add a new computer or printer. But that simplicity comes with a pretty big risk.
And that leads us to our next question. Listen closely. A network's biggest weakness is this. If its central switch fails, the whole thing goes down. So, 2-part question for you. What topology is it using? And what's at least one benefit of this design? All right, you know the drill by now. Hit that pause button, think it through, and come on back when you have an answer. Okay, ready for the reveal? The answer is a star topology. Yep, that central switch is its Achilles heel. If it goes down, so does everyone connected to it. But what's the upside? Well, the major benefit is that it's super simple and really cheap to add new stuff like computers or printers to the network.
Fantastic. Okay, let's pull back the curtain on something we do a dozen, maybe 100 times a day without a second thought, typing a website into your browser. How on earth does your computer know where to go? It feels like magic, but it's really all thanks to 2 key players, DNS and IP addresses.
Okay, so here's the secret. Computers are, well, they're not great with words. They don't understand Google.com. They only understand numbers, specifically IP addresses. So when you type in a URL, your computer has to do a lookup. It basically sends that name to something called the Domain Name System, or DNS. You can think of the DNS as the Internet's giant public phone book. The DNS finds the name, sends back the correct number, the IP address, and only then can your browser actually connect to the website. Okay, Hope you were paying attention, because it's time for a quick-fire round. I'm going to show you 3 IPv4 addresses. Your mission, should you choose to accept it, is to spot the fakes. Which ones are invalid?
Right then, here they are. Take a good look. Which ones are setting off alarm bells for you? And more importantly, why?
Go on, hit pause and take a crack at it. And I'll even give you a hint. For an IPv4 address to be valid, it has to follow 2 simple rules. It needs exactly 4 groups of numbers, and each of those numbers has to be somewhere between 0 and 255. Okay, let's see how you did. The invalid ones are the second and third ones. The one that starts with 258 is wrong because, well, 258 is bigger than 255. Simple as that. And the last one is invalid because it has 5 groups of numbers, not 4. If you spotted both of those, give yourself a pat on the back. Well done! Okay, we're in the home stretch. We've figured out how your computer finds the right address, but what about how fast it gets there? And where do we store everything these days? In our final section, we're going to get practical and talk about network speed and the cloud.
So when your internet feels slow, what's actually going on? Well, 2 of the biggest culprits are bandwidth and the number of users. The best way to picture it is to think of a highway. Bandwidth is how many lanes you have. The more lanes, the more cars, or data, can travel at once. That's why higher bandwidth means faster performance. But what happens during rush hour? Even on a massive highway, if you have too many cars, you get a traffic jam, right? It's the exact same with your network. The bandwidth gets shared, so the more people are online streaming movies or gaming, the slower it gets for everyone.
And that brings us to our final question of the day. We all use cloud storage for everything, from photos to important documents. It's super convenient, but it's not perfect. So can you name 2 key drawbacks of relying on the cloud?
So, what did you come up with? The 2 biggest downsides really boil down to 2 words: dependency and control. First, the obvious one. You are completely dependent on having an internet connection. No internet, no files. End of story. And second, you're giving up control. You have to trust a company to keep your data secure, and you're totally at their mercy if their service goes down.
And that really leaves us with a big, important final thought: the cloud. And so much of our modern tech life is a constant trade-off, isn't it? We trade control for convenience. So as we keep handing over more and more of our digital lives to these services, the question we all need to keep asking ourselves is this: what's the most important thing to remember about protecting your own data? Something to chew on. Thanks for coming along for this interactive guide.